Hi everyone, this is Puyang. I come from IoT and Detection Laboratory. We all know nowadays the growing area of fluid in the world continues to expand, and the output of fluid continues to increase. The need of automatic classification of fluid image is urgent in recent years. With the rapid development and rise of deep learning, especially in the direction of vision, it has made great achievement compared with traditional recognition algorithm. Deep learning has a stronger ability to describe the characteristic of intelligent recognition. For example, the early RCNN used a very simple detection structure. This led to very low efficiency and slow speed. Later, people proposed fast RCN and YOLO methods, which greatly improved the efficiency. The people is classification model, which is used to distinguish the object with small difference through attention, like birds. Both fast RCN and YOLO belong to target detection models, and target detection includes classification models and target positioning. I think there are deficiencies in the paper. For example, if there are two or more fruits in the picture, such as apples and bananas, the original attention single classification can only detect one type, but using target detection can detect both types, which improves with accuracy of detection. Then I will introduce my idea and experiment. The papers used the simple CN and MA, optimized location and future learning in a mutually reinforcing ways. Fix the parameters in the convolution layers and optimize the future map grouping layers in Figure 2D by LCNG in Formula 6. The purpose of the step is to locate the location, then fix the future map grouping layers and optimize the convolution layers in Figure 2B and the softmax layers in through CLS in Formula 6. The purpose of the steps is fine-grained future learning. This learning is iterators. This is mainly for positioning and mentoring. For learning from this context, I use fast SNN and YOLO to locate and detect in another ways, but the target is still the same. First of all, a fluid image classification and recognition algorithm based on convolution neural network is proposed, mainly referring to the classes convolution neural network model linear file structure, and a new convolution neural network structure is proposed. Classification and recognition of 5 kinds of fruits: apple, pears, orange, tangerines, and peaches. The model constructs an input layer, 2 convolution layers, 2 point layers, 4 connect layers, and an output layer. Single target classification of fluid image is carried out through test experiments. Second, based on the deep learning target detection algorithm, in order to demonstrate the feasibility of the algorithm, the Apple image is selected as a supposed research object, and the query mean street deep learning target detection algorithm is FastRCNN YOLO SSG select the best detection algorithm through experiment comparison. Finally, in order to deal with the interference of external factors such as lighting and angle problem. When images were collect Apple images of different size, number, and different illumination, angles were taken and improved LeNet 5 and the classes convolution neural network VGG setting and ResNet 101 as the base to extract to network and compared to modeling. Export the detection effects under the different framework model and compare the accuracy of the model by setting different hyperparameters combination proposed time to get a suitable hyperparameters combination to achieve the best detection intervals. After removing the attention, I used the FastRCNN procedures for target detection. After testing FastRCNN, I found that the speed was so slow, so I'm improved the speed based on YOLO and learning from the multi-scale detection procedures in FastRCNN, while avoiding the problem of slow speed. It can be said that multiple targets can be identified when tested with the original dataset, people, and particle. The following number is to confidence layer. Changing the detector set to a fluid data set, whether it's a single target or multiple targets, can achieve our goal. Thanks for your listen.